Hey there guys, this is AdamantLife, and you have reached episode 3 of Big Picture Python. That's my Python tutorial series where we start out with the big picture and the major concepts, and then fill in the blanks along the way. That way we can start programming early and get more experience right off the bat. So, this, as you are well aware, is Jimmy. Say hi Jimmy, and bye Jimmy, because today we're doing mostly coding stuff, so we're probably not using Jimmy today. So, I said we'd be going over list comprehensions and keyword arguments. We're going to start with keyword arguments because that's just plain easier. So, the way we have this set up right now is positional arguments. So, basically, what happens is when if we do not supply a keyword, which is what I've been doing by default down here, you can see that I supply a keyword and then assign a value to that keyword down here. That's more explicit, which is better, and easier to read and understand. But technically speaking, I can delete each of these keywords and it won't change anything. Basically, this will take each of these arguments, these positional arguments, and plug them in order. That's why they're called positional arguments. So this will go to the name argument, this will go to the sword argument, shield argument, and backpack argument. Now, like I said, keyword arguments are clearer and more explicit about what you're doing with them. At times, though, you may want to avoid using them, in which case up here, we can say sword equals none. So, basically, we can assign a default value is what I'm doing here. So with the keyword argument, you can define a default value. For right now, I'm going to do none. I'll explain why in a minute. But we're just going to set these to none for now. And then name does not have a keyword is not a keyword argument and does not have a keyword or a default value rather. The reason I'm going to leave name like this is because a lot of times when you create an object, there is going to be something unique about that object that you want to make sure is unique for it. So if you supply a default argument, that default argument is intrinsically not going to be unique. So name seems to me to be like the intrinsically unique argument here for a character. All the characters have a different name most of the time. Even if it's just Goblin 1, Goblin 2. So we're going to go ahead and leave that as a positional argument. And then we'll supply keyword arguments here. Now the reason that I do none here is because when Python reads through the script here, it's going to create this character and create this method as it's reading down the list. What that means is that if I said sword, basic sword here, it would go, alright, we've got item weights, it's a dictionary, blah, 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 blah. We've got a class character. Here's the initiation method for the character instance. Okay, name is cool. Sword, what's this? I have no idea what a sword is because it hasn't gotten this far through the code to find out what a sword is. So it's completely lost and it will start throwing us an error. What we can do if we want to make sure that a character has a basic sword to start out with, is we can check whether or not a value has been supplied for sword. So I'll do that with if not sword. We haven't gone to if statements yet. If we have time at the end of this episode, I'll go ahead and get into those. But suffice it to say that if sword would take sword and try to evaluate it as a boolean, as in it will try to evaluate sword as yes or no. Classes, if they are a class instance, are evaluated as true unless they override that evaluation within the code, which is another special method that we haven't gotten to yet. Otherwise, this will come back as none, and none evaluates as false. So we say, if not false, the opposite of this will reverse whatever the thing after it is, not will reverse whatever's right after it. So if this statement right here is true, is going to trigger right after the if statement. And I realize I'm spending more time than I really should be explaining this, but this statement, not false evaluates to true. I think you can understand that if you follow basic logic. The opposite of false is true. And then we can say sword, basic sword. And we can do that with everything else in this list. And the reason we can do this down here is because this does not get run until much later on in the script. We actually couldn't do this if we created a character. I'll do that in just a second. Right after we declared this class. Shield, if not backpack, shield. Alright, cool, awesome. So if we declared a character right here, name Jimmy, we'll say, then we would get an error as well, because it would start creating the character, start scrolling through here, and it will say, wait, a sword? No one's ever told me how to make a sword before, because, you know, obviously it hadn't gotten that far. It stops right here and doesn't get here. But in our program, in most programs, you should have any code that runs at the bottom or afterwards or in a separate file, and then load all this up first. That way you don't have to worry about this. Not worry about throwing an error here, rather. So that is that. One more thing. It's actually a rather large thing, but there are special kind of notations that we can throw in here. So normally, you can use, normally people use arg here after a star. So star is going to mean any number of positional arguments. Arg here is just the kind of accepted argument, the accepted reference name. There you go. The accepted reference name for this construction right here. And that's just short for, you know, positional arguments. And so like that, like I just implied there, that accepts any number of positional arguments. And so, like, let's say we want to give this character multiple names, for example. I'm going to go ahead and change this to aliases, just so that it's easier to understand. In that case, we can do self.aliases equals aliases. And any extra words put in here without a keyword attached to them would automatically get shoved together into this argument right here, this argument reference right here. And this is going to give us a tuple, which we haven't gone over, but very simple. A tuple is a list that is immutable, which means that it's a list that cannot be reordered, it can't be changed in any way. You can only ever, you know, kind of rewrite that reference to it. That basically you have to replace it with something completely different in order to change what a reference pointing to a tuple is. So, since that's probably not going to be useful for us, we're just going to use this list here, this list function that's built in, and that will convert an iterable into a list. And one more thing I'll do is name, comma, plus. So, basically I'll make a list here with just name in it, and then I'll combine it with the list aliases. If I did, for example, we were talking about extend last class, in that last episode, down here, you know, extend. That technically, the extend method technically returns none. So if I did self.aliases equals list aliases dot extend or dot append even name, I actually wouldn't get this list plus name. That's kind of what you would expect it to be. But that function, both of those functions, actually return none because they kind of mutate the list that they were working on in place, and therefore self.aliases, when we run this, would turn up as none instead of what we expected, which was aliases combined with name. So we're going to do it this way instead because we have to. The other way we could do it is have, you know, take this here, aliases equals list aliases, and then aliases dot append name, and then assign aliases here. Again, this is more typing, so that's why I'm not going to do it this way. because this is plenty understandable. This is going to say, self.aliases is equal to a combination of this list plus this list. And that's perfectly easy for us to look at and understand. And this might be useful, I'm just thinking out loud here, having this aliases thing might be useful if, you want to have different names for your character, and then you can change names in the option menu or something like that. And therefore, there will be a place to keep all those names. And then we just change self.name whenever the player or the user wants to change what alias is being used, is being displayed on the screen. So that's useful. The other thing we can do, so we had this special character here, special reference here for positional arguments. There's also a special reference for keyword arguments. And again, the kind of like arg over here, ARG, was the accepted phrase to use for positional arguments. Double star and then KW or KWARG, keyword args. Either of those work. I've seen both of those used. And just like this captures any number of positional arguments, keywords is going to accept any number of keyword arguments that is not in this list right here. So if we give it like spells or special attacks, spells and special attacks with their values would end up here in keywords, KW and KW. And KW is a dictionary. So it's going to have the keyword as the key on the dictionary and the value for the keyword as the key value in the dictionary. So I'll just go ahead and this basically is only ever really useful for, superclasses and whatnot, which we'll get into in another episode. So we can just accept all these different arguments that belong to something higher that we're going to pass on, and then just pass them on instead of having to list them all out, because I could have a whole bunch of keyword arguments here. This could be like 3 lines long, of keyword arguments. But this specific class only worries about name, aliases, sword, shield, backpack, It doesn't care about spells or special attacks for whatever reason. So that's one way to capture those extra things that this specific class doesn't need, but classes that are a parent of it would need. And again, we'll go into what exactly I'm talking about there, so if it's confusing you, don't worry about it, just forget about it. Otherwise, you really shouldn't be using this just to make life easier for you. You really should just be parsing. If you get a whole bunch of keywords and values from someplace, like for example, when we start saving data into files and stuff like that, you really are better off just sanitizing that data, which means, parsing it all out and making sure it's all reasonable data to get plugged into here. So, we don't want to just throw this in here just so that we never have to worry about what we're being given again. But for now, we will. For now, we'll just create a special extra keywords attribute on this character instance that just takes the keywords for us. And again, just to reiterate, because it's kind of important, keywords here is a dictionary. You'll see this doesn't have the 2 stars down here, and this doesn't have the single star here. That's because these are just marking what they are in the constructor line, okay? Once they get down here, then they're just a reference. So you don't have to worry about putting, double stars right here. So let's come down here. We don't need 2 backpacks, so I'm going to go ahead and just use the dictionary backpack from now on. And I will comment those out. And same deal here, we'll comment this out, comment this line out, change, that can stay actually as it is because backpack gets a name, and it goes right to the dictionary backpack, so that should be fine. But we have to pull the 2's out of here because we're just using a regular backpack now, our default backpack. And all this extra printing stuff we will clear out for now. So, just to get this code reflecting the changes that we made up top here. Jimmy, some other aliases for Jimmy is Jimbo, James, And then sword, shield, backpack, I said special attacks. We're not really worrying about it, so I'll just say equals none, and spells equals none. And there we go. If we print, just to make sure that everything's working correctly, print Jimmy.aliases. So what we're expecting from Jimmy.aliases is Jimmy, Jimbo, James, because it will combine Jimmy, which is the name, and Jimbo and James, which is in the aliases thing, when it assigns aliases to Jimmy. And then print Jimmy.extra keyword. Did I add an S on there? No, I didn't. Alright, yeah, so Jimmy.extra keywords. Save and run. And there we go. There's our keywords. Again, you can see this is a dictionary. So keywords, special attacks is the key, with none as the value. Spells, none as the value. And then per expectations, our name is first here, and then these came in the exact order that we were given them. This was one list, this was added as another list to this list, and now we have one list in the aliases. So everything is looking squeaky clean and exactly as we would like it. So that brings us on to the next thing that we want to do, which is list comprehensions. Now, before we go on to this, you should have a good understanding of what went on here. How we went and took these lines and broke them down into a single line here. Because, as I kind of alluded to last time, we're actually going to break this into a shorter line. So I'm going to copy these out, put them here for now, and then I'm going to go ahead and so that this doesn't get too obnoxious to look at, I'm going to actually make it green. That way we're not seeing red all over the place. So what we're going to do, a list comprehension, well, comprehensions in general. So comprehensions come in several different kinds. It's basically a generator, which means that it's going to iterate over and create stuff, okay? But we're going to cast it in square brackets to make it a list. We could also use list like that because a generator is iterable, and then just stick the generator in here. But almost no one ever does that. I've always seen it like this. So what are we going to do? We're going to do basically for item in dictionary. So let's just cut that, paste that, get rid of the colon. So what are we looking for when we're iterating through this item in dictionary? We're looking for this, yeah? So for item in dictionary, actually, instead of, let's not get too ahead of ourselves. We're looking for item weights, item. So that's one thing we're looking for. So if we ran this right now, what it does is it takes this, chunks this off, and then does this afterwards. That's what a list comprehension basically does. It says, for item in dictionary, item weights that dictionary. And it puts this at an index in the list, in a new list, where this item would normally be indexed. That's not entirely true. Only because I don't have a validator right here. So the next index, I'm going to say. So on our first thing through, this is going to be at index 0. If for some reason the second item in our dictionary evaluated false because of an evaluation we're going to put over here, evaluation, I'll just do it like that for now. So if we had an evaluation over here and this was open like this, and this second one turned up false, then the third one, if the third one turned up true, would actually go in the next slot in this list, which would be the first index, or, because we go 0 index, 1 index, 2 index, etc. So it would be the second item in this new list, even though it was the third item in the dictionary list. So long as you're following along with that, we need item weights. and then we need, then we're going to also want to get the kind of net value, net item weight. So we need the quantity and that, and what this is going to print. Let's go ahead and just run this to show you what it prints out. So if you are following along with it, this part got lifted from down here, well, down here, and then this part is the for loop. So that's all list comprehension is. The biggest problem with list comprehensions is when you're not reading correctly, because you got to go from smallest to biggest, and this part has to be described adequately by anything that comes over here. And the reason I say that is because sometimes we're iterating over multiple things after this first argument, this argument that's going to be our value in our end list, the list that we have at the very end. And at that point, if anything here is not adequately explained over here, then we're going to have a problem. So we're going to go ahead and do that, and we're going to run it really quick. And, whoops, we didn't actually get Jimmy's backpack weight this time because we got rid of that. We deleted it. So Jimmy.backpack.getWeight. There we go, and now it should print. So we got a list right here, and let me get that. And what did it print out? It printed out a list, because this is a list comprehension, and in the first slot was the first thing it pulled out, the first item it pulled out of the dictionary, thrown into this item weights and multiplied by the dictionary's value for that item. And then same thing for the second one and the third one. So I said we are going to tighten this up even further. The last thing that we're going to do with this weight, weight function, is we're going to sum this iterable. So now you just saw that list that we had. Sum goes through the list and adds it all together. It's looking specifically for numbers. There are different things you can do to make it accept other things, but we're going to go ahead and leave that for another time just because we don't need that right now. And 90% of the time, you're going to be summing numbers, not non-numbers. So as is, right out of the box, this sum function will take each of the numbers in this list and add them together. So instead of having to, have a starting weight and then reassign starting weight on each step, it's going to get all these steps first, make a list out of all these steps, and then add all these steps together all at once. So instead of going starting weight plus weight equals starting weight plus weight equals starting weight plus weight equals starting weight, instead it's going to say, okay, weight, 3 items in a list, and then, okay, add all those items in the list together and return them. And we're going to just go ahead and return that. And there we are. At this point, we've gotten all this stuff. You can see actually, let me, for posterity's sake, go like this. There we go. So, we've just turned this whole entire function right here, all the stuff that are going on, into a simple one-line summation of a list comprehension. And again, if this is too complicated for you and you're not understanding it, then you can break it down. However, so long as you understand list comprehensions, then this should be fine. If you have to, okay, break this down into steps with your, because this is within square brackets, kind of like how I told you within parentheses, you can create a new line and it will just keep on reading until it hits the end one. You can do the same thing with square brackets and curly braces. So you can go ahead and hit enter right after this first part and say, okay, the first line is what I'm getting each time I iterate through. The second line describes how I'm iterating. And the third line has any validations that I need. So if item is greater than 5, let's say, or if weight, item weight's item is greater than 0. So, for some reason, if I don't want any zeros in the sum, I can just peel them out that way. Not a very useful thing to do, I'll just mention, but for some reason you may want that. So, that is how those work. Let's see if we can't find another. Yeah, okay. So, really quick, we will create another list comprehension just to get some extra practice with it, because it is a little tricky at first. Like I said, I find them personally fun, especially when we get into more complicated examples of list comprehensions, but you probably need some more practice. So, really quick, I'm going to ask you to write a single line that gets the sum of all items in the backpack that have a net weight less than 2. So go ahead and pause the video right now, and I will resume. Well, you can resume when you have it written. Alright, so what I would do is I would print sum, and I'm just going to close my parentheses ahead of time. That's a habit that I like to get in, that I'm into, is to close all my statements before I start writing in them. Print sum item for item in Jimmy.backpack.contents. And what would we want? We want item weights, item times, and I said net weight, I believe, so Jimmy.backpack.contents item. So this, just to do what I said before about breaking them into lines if you need some help. So there's that, and then I would, and everything that was net weight less than 2. So I'll just copy this down, is less than 2. And then I'm going to get the sum for that. I'm not sure if I said sum, so we can actually go ahead and make another, if I didn't say sum last time, then pause the video right now, and when we come back, we'll make another one that lists the items that have a net weight less than 2. Alright, cool. So you should be unpaused by this point, and if you hadn't paused, then pause really quick. Alright, fine. So let's just, whoops. I'm just gonna, yeah, alright, fine, I'll do it from scratch. Print, item for item in Jimmy.backpack.contents. And I'll go ahead and break these into lines for you until you're used to it. If, oh, I missed my if here. Whoops. So hopefully you didn't try to run the program before I got that if in there. If item.weight is less than 2. So there we go. In this case, I'm returning item.name. So we get the item name for each item in Jimmy's backpack contents if the net weight of that item is less than 2. And we will go ahead and let's just get rid of these for now and run. Oh, very good, very good. Our items aren't, we haven't made item class yet. That's why that failed just now. I was getting ahead of myself. I was thinking next episode we were going to do classes in item class. Spoiler alert. So it's just item. So there we go. So the net weight of all our items that weigh less than 2 pounds is 0.4 pounds. And those items are candles and caltrops. One more list comprehension since we need the practice. So this time, I want you to, how do I want you to do this? I want you to replace this right here. This is actually going to require a bit of homework. So when you pause this, I will tell you when to pause in a second. You're going to want to look up dictionaries in the Python documentation and try to figure out how we can get the value for a dictionary by iteration. So go ahead and pause, try to look that up. If you can't, no worries, I will show you in just a second, but it is good to be self-sufficient because I'm not going to be here doing your homework for you all the time. So 3, 2, 1, and pause. Okay, so the way that we can do this, print sum, and my brackets, space it out for you guys. Item weights is going to be the same. Item is going to be the same. Times, and then we're going to need a value here is what we're looking for. A quantity, I'll call it. And then we got to figure out how to iterate over here. So what happens here is dictionaries have a special method. Jimmy.backpack.contents is our dictionary, called items. And items supply a two part tuple, a 2-index tuple that contains the value or the key followed by the value. So what we can do here is item, comma, quantity, because the item in our dictionary is the key and the value for the item is our quantity. So at this point, then we can, I'll copy this down to save time, replace that with quantity, and now this is a lot shorter. So when we iterate over jimmy.backpack.contents.items to reiterate, we're going to get a tuple. Let me just throw those in there. And that tuple, the first part is going to be item, the second part is going to be quantity, and then we can take those and refer to them individually as, you know, their references. We can refer to them, reference them individually. So I can have the key here to plug into item weights, and at the same time that I'm iterating, get the value, which is the quantity, and then we can multiply the weight by the quantity right here. And that cleans this up a whole bunch. You know, now we don't have continual references to jimmy.backpack.contents. So we're just going to run really quick. And we see we got the same value as we got before. Looks like it's working appropriately. It is. Don't worry about it. And the one thing we'll just do, since we had to do that, is we'll add that method to our class. So .items self return self.contents.items. Real simple. So now this backpack, instead of saying backpack.contents.items, we can just say backpack.items. So when we call the Jimmy backpack items, we get tuples, a list of tuples for the item and the quantity. And one last time, I will go ahead and print jimmy.backpack.items, just so that you can see how that looks. We run, and you see this says dict items. That's because technically speaking, this is not strictly speaking a list of tuples. It's technically a dict view, which is not something you really need to worry about at all. It's going to function for all intents and purposes as a list, so you don't have to worry about that. But it's just something to keep in mind that I will mention. And then these are tuples right here with the parentheses. So you can see that's the key, and then the value or the quantity, item key, value quantity, item key, value quantity. Very good. So that looks like that wraps us up for today's episode. Learned quite a bit. That was quite interesting. As I mentioned, we will do superclasses and classes, and we will make an item class to facilitate that. And that will be next episode. So, if you haven't already, please like, favorite, subscribe. And I haven't said so, but obviously leave comments. Those are always welcome. And have a wonderful day, afternoon, or evening, wherever you're at in the world. I will catch you later.